Welcome to the Security Objects module. This module explains security zones objects and their types. The module also describes screen objects, address objects, and service objects. At the end of this module, you will be able to explain security zones objects, describe screens objects, describe address objects, describe service objects. A zone is a collection of one or more network segments sharing identical security requirements. To group network segments within a zone, you must assign logical interfaces from the device to a zone. Zones define the security boundaries for the Juno security device and form the basis for security policy matching against transit traffic. Security policies reference a source zone and destination zone to regulate traffic through the Juno security platform. Logical interfaces must be assigned to zones to accept and pass traffic. By default, all network interfaces belong to the system-defined null zone. All traffic to or from the null zone is dropped. Special interfaces, including the FXP0 Management Ethernet Interface, Chassis Cluster Fabric Interfaces, and internal system EM0 interfaces, cannot be assigned to a zone. The graphic summarizes the logical relationships between interfaces, zones, and routing instances. Logical interfaces are connections to specific subnets and can only belong to one zone. Zones are groupings of logical interfaces with a common security requirement. Zone configuration can be as simple as a two-zone setup, where all interfaces connected to internal networks are in one zone and all interfaces connected to the external networks are in a different zone. A more advanced configuration might divide interfaces based on internal department or function, in addition to external and DMZ connections. A physical device can be broken up into multiple routing instances. A routing instance is a logical routing construct within a platform running Juno's OS. Each routing instance maintains its own routing table and forwarding table. A routing instance can contain one or more zones, which cannot be shared with other routing instances. The zones within Juno's OS can be subdivided into two categories: user-defined and system-defined. You can configure user-defined zones, but you cannot configure system-defined zones. You can subdivide the user-defined category into security and functional zones. Click each zone type to learn more. create a zone, first navigate to the Configure, Security Services, Security Policy, Objects, Zones, Screens hierarchy. Click the Add button to create a new zone. Zone configuration involves 4 steps. First, you define a security or a functional zone. Next, add logical interfaces to the zone. Optionally enable some system services and protocols destined to the device itself, also known as self-traffic. If you omit this step, all traffic entering through the zone's interfaces destined for the device is blocked. Next, specify the name of the zone with any non-reserved name you prefer. Note that user-defined zone names are case-sensitive and can contain any standard characters, like any other variable name in Junos OS. Functional zones must be named Management. Once a zone is created, you can assign logical interfaces to the zone as displayed. Traffic destined for a Junos security device is not permitted by default. You can specify the types of traffic accepted into the device using the Host Inbound Traffic tabs. The Host Inbound Traffic settings can be configured for a logical interface or an entire zone, depending on which tab is selected. If there is no configuration on the Interface tab, that interface will inherit the zone Host Inbound Traffic settings. All outbound traffic originating from the device is allowed by default. When configuring Host Inbound Traffic, you can specify the available services and available protocols configuration options. Options in available services vary, but generally refer to administration options such as SSH, JWeb, SNMP, and ping. The available protocols section generally refers to routing protocols. You can refer to all system services on their respective ports with the All keyword. For example, SSH would be open only on port 22. To open all ports for all services, use the Any Service keyword. When host inbound traffic is configured in both the interface and zone locations, then the interface level configuration is implemented and no zone level settings are inherited. An example of zone configuration is displayed. What types of traffic are permitted into the specified zone and interfaces? In this example, a security zone named HR is configured. Interfaces GE0/0/1.0 and GE0/0/4.0 belong to that zone. Inbound SSH and FTP traffic are permitted into the device through these interfaces. All other inbound traffic that are local to the device on these interfaces are dropped. Here is another example of zone configuration. What types of traffic are permitted into the specified zone and interfaces? In this example, a security zone named HR is configured. The GE0/0/1.0 and GE0/0/4.0 interfaces belong to that zone. The zone configuration enables only SSH and FTP as system services. The GE0/0/1.0 interface has no specific configuration, so it inherits the zone-level configuration that enables SSH and FTP only. The GE0/0/4.0 interface has specific configuration that enables only SNMP as a service. Therefore, the zone-level configuration is overridden. SSH and FTP will not be permitted through the GE0/0/4.0 interface. The Junos host zone is a system-defined zone. You can configure the Junos host zone in a security policy to provide granular control over which traffic is permitted in or out of a security zone on the Junos security device. When the device receives traffic destined to itself, it first examines whether the destination of the traffic is the incoming interface. If so, Junos OS confirms if the service or protocol is enabled on that interface by referencing the configuration under the Host Inbound Traffic tabs for the zone or interface. If the traffic is permitted by the configuration, then Junos OS confirms if there is a Junos host zone security policy. If there is a Junos host zone security policy that matches the traffic is acted upon based on the action in the policy. If no Junos host zone security matches the traffic, then the traffic is permitted. If the traffic is destined for an interface other than the ingress interface, for example, the loopback interface, then Junos OS first evaluates security policies to determine if the traffic is allowed. If the traffic is permitted, then host inbound traffic configurations are verified, and then Junos host zone policies are verified. By default, Junos OS permits all outbound traffic. If some of this traffic should be dropped, you can create Junos host zone security policies to restrict traffic on egress. Screen options evaluate Layer 3 and Layer 4 headers to detect and block various types of malicious traffic, including anomalies and denial of service or DOS attacks. They enable Junos security devices to protect against more than 30 different internal and external attacks, including SYN flood attacks, UDP flood attacks, and attacks abusing the IP options field. When applied, screen options apply to ingress traffic. Screen checks are applied to traffic prior to security policy processing, reducing resource utilization. Before implementing any security feature, it is best to know the traffic types and patterns traversing your network. Screens can drop legitimate traffic from off the network. Recall the packet flow through a Junos security platform. Once the packet enters a flow module, the device examines it to determine whether it belongs to an already established session. Junos OS matches on 6 elements of traffic information to identify a session: source IP address, destination IP address, source port number, destination port number, protocol number, and a session token. Beyond offering protection against malicious attacks, a major advantage of using screen options is to reduce the resources used to process malicious packets. Resources are saved by dropping malicious packets before incurring the overhead of performing route lookup, policy lookup, and session creation. To determine the appropriate thresholds for limit-based screen functions, you must first know what is typical of your network. For example, if you want to enable SYN flood protection, you must first determine what constitutes an acceptable number of connection requests. This determination requires a period of observation and analysis to establish a baseline for typical traffic flows. You must also consider the maximum number of concurrent sessions of the particular Junos security device you are using. Typically, you want to deploy screen options only in vulnerable zones. To test screens, you can use the Generate Alarms Without Dropping Packet checkbox as displayed. Traffic being evaluated by the screen triggers a log or alarm for any configured events, but no action is taken on the traffic. The gathered information may help you to better understand your network's vulnerabilities. You should understand normal traffic patterns on your network before implementing screen options. Failing to do so might adversely impact legitimate traffic and create unhappy users. This includes understanding applications and their behaviors, as well as patterns of the traffic traversing your network. For example, if a legitimate application in your network uses large internal control message protocol or ICMP packets, enabling the ICMP large option, which drops large ICMP packets, would negatively impact the network. Beyond offering protection against malicious attacks, a major advantage of using screen options is to reduce the resources used to process malicious packets. Resources are saved by dropping malicious packets before incurring the overhead of performing route lookup, policy lookup, and session creation. Screen options are applied at the ingress zone only. Without a route and zone lookup, the egress zone is unknown, and therefore traffic cannot be evaluated by the egress zone screen. Because the screens on the ingress zone are the only options processed, ensure you apply the screen to the zone you want protection from. Screen options fall into two different types: anomaly-based options and flood-based options. Both types are processed by the flow module but are handled differently. Click each screen option type to learn more. When configuring a screen option, there are 4 configuration stanzas to consider: ICMP, IP, TCP, and UDP. A separate configuration section for firewall session limits exists outside the 4 major protocols. Screen options that apply to ICMP traffic only evaluate information in the IP and ICMP packet headers. Some ICMP options also track ICMP traffic within the zone. IP-based screen options evaluate information only in the IP header. TCP and UDP screen options evaluate information in the IP and TCP or UDP header. TCP and UDP screen options can also track TCP or UDP traffic within the zone. The session limit screen differs from most others in that it tracks all sessions within the zone irrespective of their IP protocol. The example illustrates configuring screen options. First, you must define the screen, which acts as a container for all the individual options you want to enable. Select each tab to configure the required screens for this container. Then you must apply it to the desired zone. You can apply each screen to one or more zones as needed, but only one screen can be applied to each security zone. Screens are a great way to stop some well-known attacks using minimal resources. When writing security policies, using an exact IP address or subnet in defining traffic flows is very important. The policy itself does not accept an IP address or subnet during configuration. An address object that represents the IP address or subnet must be created beforehand. Zone address objects are created under a specific zone and can only be used by that zone. They must be given a unique name that references an IPv4 or an IPv6 subnet. Before Junos 11.2, this was the only way to make an address object. Global address objects are about the same as zone address objects, except they are not associated with a zone. Since there is no association, the global address object can be used in any of the security policies, regardless of the zone context that the policy might be in. There are 4 types of address objects. Click each type to learn more. The process that you must use when creating address book entries is shown. A security policy can reference individual addresses or address groups. Address groups are useful when you must refer to a group of addresses more than once. Individual addresses and address groups both enable changes to be made quickly. Only updates to the address book entry must be made for security policies to implement the changes instead of needing to update each individual security policy. If the matching criteria in a policy does not need a specific address, then no address book entry is necessary, and you can use the Any configuration option. An address book entry can either be a single IP address using a /32 subnet mask or a range of IP addresses using a variable length subnet mask, such as /24 or /28. When Junos OS is evaluating the source address in a security policy, it attempts to look up the address object in the address book attached to the source zone. Similarly, a lookup of the destination address is done in the address book attached to the destination zone. However, zone-based address books are less flexible, since some addresses may need to be reused in multiple address books. The address objects are also not available for use in other types of policies, like intrusion detection and prevention, or IDP. The example illustrates the process to create address object entries. These objects are placed in a global address book and are able to be used in any zone context configuration. It is now a best practice to use global address books. Zone-based address books will be discontinued in a future software release. These global address books are made to organize the addresses within the global address book. Global address books must be given a unique name and can then be attached to one or more security zones. Each security zone can only have one address book associated to it, with the exception of the global address books that are not attached to any zone. The Upgrade button is there to assist you in converting zone-based address books to global address books. Set a unique address book name and select the zones that the address book will be attached to. Click the Add button to add address objects to the newly created global address book. In the Add Address pop-up box, enter a name with no spaces for the address object. Then select the address type and add an appropriate value for that type. Click OK, and then add another address or click OK to move out of the Add Address book workspace. An address book can grow to contain large numbers of addresses and become difficult to manage. You can create groups of addresses called address sets to manage large address books. Using address sets, you can organize addresses in logical groups and use them to easily configure other features, such as policies and network address translation or NAT rules. The predefined address set, any, which contains both any IPv4 and any IPv6 addresses, is automatically created for each security zone. You can create address sets with existing users or create empty address sets and later fill them with users. When creating address sets, you can combine IPv4 and IPv6 addresses, but the addresses must be in the same security zone. You can also create an address set within an address set. This enables you to apply policies more effectively. For example, if you want to apply a policy to two address sets, set 1 and set 2, instead of using two entries, you can use just one entry to apply the policy to a new address set, set 3, that includes address sets set 1 and set 2. When you add addresses to policies, sometimes the same subset of addresses can be present in multiple policies, making it difficult to manage how policies affect each address entry. Reference an address set entry in a policy like an individual address book entry to enable you to manage a small number of address sets, rather than manage a large number of individual address entries. Creating an address set is similar to creating an address object. Switch to the Address Sets tab on the Edit Address Book workspace and then click the Add button. Enter a unique name with no spaces. For the address set name, select the Addresses and Address Sets to include in the new address set. Click OK to save and return to the Global Addresses workspace. Zone-based address objects are being phased out, and global addresses are replacing them. Global addresses can be used in any policy regardless of zone context. Global address books can be created for the purpose of organizing addresses for easier management. When a global address book is attached to one or more specific zones, the addresses in those books are restricted to policies using the same zone context. Service security objects are application definitions to use in policies. Applications are types of traffic for which protocol standards exist. Each application has a transport protocol and destination port number or numbers associated with it, such as TCP port 21 for FTP and TCP port 23 for Telnet. When you create a policy, you must specify an application for it. You can select one of the predefined applications from the application book or a custom application or application set that you created. Each predefined application has a source port range of 1 to 65,535, which includes the entire set of valid port numbers. This prevents potential attackers from gaining access using a source port outside of the range. If you need to use a different source port range for any predefined application, create a custom application. The predefined applications from Juniper networks start with a Junos header. It is recommended that custom applications names refrain from beginning with the Junos header. Custom policy application is an alternate feature for predefined policy applications. If you do not want to use predefined policy applications in your policy, you can create custom applications. Junos OS enables you to configure custom applications for your policy. When you create a policy, you must specify an application or service for it to indicate that the policy applies to traffic of that type. Sometimes the same applications or a subset of them can be present in multiple policies, making it difficult to manage. Juno's OS enables you to create groups of applications called application sets. Application sets simplify the process by enabling you to manage a small number of application sets rather than a large number of individual application entries. You can specify the name of an application set in a policy. In this case, if all the other criteria match, any one of the applications in the application set serves as a valid matching criteria. Any is the default application name that indicates all possible applications. In addition to predefined services, you can configure a custom service. After you create a custom service, you can refer to it in a policy. Welcome to the lab section of this module. In this lab, you configure security objects that security policies use to control how traffic traverses the VSRX1 device. At the end of this lab, you will be able to configure security zones and host inbound settings, configure security screens to block abnormal traffic, configure security address objects, configure security application objects. Click the Start button to view a guided demonstration of the lab tasks. Part 1. Loading the baseline configuration. In this lab part, you become familiar with the access details used to access the lab equipment. After this, you use the JWeb interface of the VSRX devices to load the starting configuration for Lab 2. Click each step number to view the step. Consult the management network diagram to determine the management addresses of the devices. Access the JWeb interface of VSRX1 using a web browser. Refer to the management network diagram for the IP address associated with VSRX1. From the Open Web Browser to VSRX1, log in to the VSRX1 device with lab as the username and lab123 as the password. Note that both the name and the password are case-sensitive. Navigate to the Administration, Devices, Config Management, Upload Workspace in JWeb. Click Browse. Navigate to the Administration, Devices. Click Browse. Part 2. Configuring security zones. In this lab part, you configure security zones using the Juno's JWeb and host inbound traffic settings. After this, you test and compare the zone and interface host inbound traffic configurations. Click each step number to view the step. Return to the Open Web Browser to VSRX1. Navigate to the Configure, Security Services, Security Policy, Objects, Zones and Screens workspace in JWeb. Click the Add button to begin adding a new security zone. Create a zone with the name DMZ and add the GE0/0/2.0 interface to the zone. Examine the zone list. Select the Trust Zone and edit it to allow only SSH and HTTPS control traffic. Click the Host Inbound Traffic Zone tab. Remove all from the selected services and then add the SSH and HTTPS services. Click the Host Inbound Traffic Interface tab. Select the GE0/0/1.0 interface and then add Telnet as a service. Click OK when complete. Examine the Zones and Screens workspace to verify your settings. Commit the changes to the configuration. Examine the Monitor, Interfaces, Ports workspace to view the host inbound services allowed by the interface. Verify the host inbound settings. Access the CLI of VSRX VR using either the console or SSH. Refer to the management network diagram for the IP address associated with VSRX VR. From the CLI of VSRX VR, log in with lab as the username and lab123 as the password. Note that both the name and the password are case sensitive. Initiate a Telnet session from the host in the trust zone to the VSRX1 host by issuing the Telnet 10.10.101.1 routing instance trust command. Log in with lab as the username and lab123 as the password. Close this session by using the exit command. Initiate an SSH session from the host in the trust zone to the VSRX1 host by issuing the SSH 10.10.101.1 routing instance trust command. Return to the open web browser to VSRX1. Remove Telnet from the host inbound traffic settings on the GE0/0/1.0 interface. Return to the Configure, Security Services, Security Policy, Objects, Zones, and Screens workspace. Select the Trust Zone and click the Edit button. From the Edit Zone pop-up window, click the Host Inbound Traffic Interface tab. Then select the GE0/0/1.0 interface. Select Telnet from the Selected Services window and move it back to Available Services. Commit the changes. Return to the Open CLI session to VSRX VR. Initiate an SSH session from the trust host to the DMZ host by issuing the SSH 10.10.101.1 routing instance trust command. Answer yes to any questions and log in with the lab123 password. Issue the exit command to close the SSH session with the DMZ host. 20. From the open session to VSRX VR, initiate an SSH session from the trust host to the DMZ host by issuing the Telnet 10.10.101.1 routing instance trust command. Part 3. Configuring screens. In this lab part, you configure screens and assign them to a zone. After this, you perform a test to verify the screen's operation. Click each step number to view the step. Turn to the open web browser to VSRX1. Ensure that you are in the Configure, Security Services, Security Policy, Objects, Zones and Screens workspace in JWeb. Click the Screen List tab and click the Add button. A moment to click the tabs on the Add Screen pop-up window to see the available options. Click the Denial of Service tab and select the Large Size ICMP Packet Protection option. Click the Apply to Zones tab and move the DMZ zone to the selected column. Click OK when complete. Click the Zone List tab again and verify that DMZ screen is attached to the DMZ zone. Select the DMZ zone and click the Edit icon. Click the Host Inbound Traffic Zone tab and move the ping service from the Available to the selected column. Then click OK. Verify that the DMZ zone has ping in the Host Inbound Services column and DMZ screen in the Screen column. Click Commit Options and select Commit to apply the configuration changes. Return to the Open CLI session to VSRX VR. Initiate a ping from the DMZ host to the VSRX1 host by issuing the ping 10.10.102.1 routing instance DMZ count 5 command. Return to the open web browser to VSRX1. Navigate to the Monitor, Security Services, Screen Counters workspace. Select DMZ from the Type drop-down menu. View the Screen Counter Hits section at the bottom of the screen. Return to the Open CLI session to VSRX VR. Initiate a large ping from the DMZ host to the VSRX1 host by issuing the ping 10.10.102.1 routing instance DMZ count 5 size 60,000 command. 13. Return to the open web browser to VSRX1. Ensure that you are in the Monitor, Security Services, Screen Counters workspace. View the Screen Counter Hits section at the bottom of the screen. Part 4. Configuring global addresses and address sets. In this lab part, you configure global address books with multiple addresses and then add the addresses into address sets. Click each step number to view the step. Return to the open web browser to VSRX1. Navigate to the Configure, Security Services, Security Policy, Objects, Global Addresses workspace. Open the Global Address Book. Select the Global Address Book and click the Edit button. Ensure that the Addresses tab is selected and click the Add button. Create a new address book entry for the Internet host in the Untrust zone with the displayed parameters. Verify the new entry and click OK. Create another address book by clicking the Add button. Name the address book DMZ Book and select the DMZ zone to attach it to. Ensure the Addresses tab is selected and click the Add button. A new address book entry for the DMZ network in the DMZ Book address book with the displayed parameters. Create a new address book entry for a web server in the DMZ book address book with the displayed parameters. Create 2 more web server address objects in the DMZ book address book using the displayed parameters and click OK. Verify the new address objects in the Configure, Security Services, Security Policy, Objects, Global Addresses workspace. Select DMZ Book in the Configure, Security Services, Security Policy, Objects, Global Addresses workspace. Click the Edit button. Click the Address Sets tab and click the Add button. Create an address set with the name of Web Server Set and add the Web Server 01, Web Server 02, and Web Server 03 web servers. Verify the Web Server Set address set. The Configure, Security Services, Security Policy, Objects, Global Addresses workspace shows an overview of the global addresses. 17. Commit the configuration to apply the changes. Part 5. Configuring service applications and application sets. In this lab part, you configure a custom application and an application set. Click each step number to view the step. Return to the open web browser to VSRX1. Navigate to the Configure, Security Services, Security Policy, Objects, Services workspace. Click the Predefined Applications tab. View the predefined applications that Juniper Networks includes in Juno's OS. Note, there are 8 pages of applications. 3. Click the Custom Applications tab and click the Add button. 4. Create a custom application with the displayed parameters. 5. Click Yes to confirm the creation of the My App application. Click the Application Group tab and click the Add button. Create a new application set using the displayed parameters. Confirm the creation of the Web Server App Set application group name. Verify the creation of the application group. Click Commit Options and select Commit to apply the configuration change. 11. Return to the Open CLI session to VSRX VR. Exit the CLI session by issuing the exit command. You have reached the end of this module. In this module, you learned to explain security zones objects, describe screens objects, describe address objects, describe service objects.